Alright, today we're going to be talking about finding or looking at geometric series and sequences in series, and talking about what exactly is a geometric sequence and how to find the sum of part of a geometric series. First of all, the difference between a geometric series and an arithmetic sequence. The geometric series is a sequence of numbers where there is a common ratio. So what this means, instead of having the same thing that is added to the next term, we are going to have the same number being multiplied to get to the very next term in the sequence. So we're looking for sequences that go from one term to the next term by multiplying the same number throughout. So if we look at this first example here, it goes from 1 to 2. How do we get from 1 to 2? We are multiplying by 2. We are multiplying by 2. We are multiplying by 2. So it is consistent throughout, therefore the common ratio is 2. We take the next two and see if you can come up with the common ratio. What is being multiplied by each of the terms to get to the next term? So here we see that the denominator is being multiplied by 10, which means that we are multiplying by 1 over 10 every single time. Therefore, the common ratio is 1/10. Now, if you're ever unsure what you are multiplying by, you could take the next term, say like -12, and divide it by the previous term. And that would give you that we have a ratio of -1/4, and prove that it's the same by doing 3 divided by the previous term of -12, and gives you -1/4. And you don't have to do this, but this is a way to double check if you don't know what the common ratio is. But this proves that it's consistent, and we have a common ratio of -1/4. And just like in an arithmetic sequence, in a geometric sequence, we have a formula that we're able to find a specific term within the sequence. So in this specific formula, we need to know what the first term is, we need to know what the ratio is, and then we need to know what numbered term we are talking about. So if we look at this first sequence here, we can find that the first term obviously is 2. And then we need to find the ratio. What is being multiplied to get from 2 to 6, and then 6 to 18, and 18 to 54? We're multiplying by 3. So we have a common ratio of 3. At this point, we're just plugging directly into our formula here to find the 10th term. So we know we want the 10th term, which means our n value over here is going to have to be 10. So we plug in our first number of 2 times the common ratio of 3 to the 9th power, because 10 minus 1 is 9. Now, biggest mistake that people will make is they will multiply 2 times 3 first. We need to make sure that we use order of operations and do the exponents first, and do 3 to the 9th power, and then multiply by 2. And we should get a 10th term of 39,366. Now, in a geometric series here, we're talking about terms that have a common ratio, just like we talked about, but we can find the sum of them, and we're going to be using this formula right here, which is incorporating how many times the ratio is being used, and we're finding a partial sum, because it's not a sum of the entire series, because we are cutting it off at a certain amount of numbers. So in our first example here, finding the sum of these first 8 terms. So we recall the formula here. And if you can just look at the formula for a second, this is really important that we remember our order of operations here, because we need to make sure that when we type this into our calculator, a lot of times when people type in the entire thing here, we need to make sure that we understand that the exponents need to happen first, and then we put parentheses around the denominator, because we want to divide by 1 separately and then subtract the ratio. So if we look at this particular problem here, we can see that our first term is clearly 1. And then what are we multiplying by? It's actually kind of spelled out for us because it's just changing by 3. This is 3 to the first power, 3 to the second power, 3 to the third power, etc. So our ratio is 3. And it's telling us to find the sum. We already have our addition signs in there. So when we plug this in, the sum of the first 8 terms is, the first term is 1. 1 minus the ratio is 3. We want the first 8 terms, so it's to the 8th power, all divided by 1 minus the ratio. So all I did was plug in from the formula there. Now if you carefully plug that in, we should get a sum of the first 8 terms is 3,280. And we go to the next one. This one we want the sum of the first 5 terms. So go ahead and take a minute, see if you can plug in, set up what the formula would be if we were plugging in for the first term and the ratio. And see the ratio, I'm sorry, the first term is 2. How do we get from 2 to -1 and 1 to 1/2? The ratio is -1/2. This time when we plug it in, when you're typing this in, you might want to put -0.5, but make sure you use the proper parentheses in order to find the sum here. And when you type this in, then you're simplifying, you should get the sum of the first 5 terms is equal to 1.375. Now this one is the same thing. It's telling us to find the sum. It's just written in the summation notation. So this is again telling us to find the sum from the first term to the 5th term. So it's really the first 5 terms. And it is a geometric series because we have this ratio being used to this power, and we could verify by putting 1/10 to the first power, which is 1/10, and then 1/10 to the second power is 1/100, and 1/10 to the third power, and we can see that we're clearly multiplying by 1/10 in each case. So to find the sum of the first 5 terms, we have our first term, which is 1/10, and then our ratio is also 1/10 to the 5th power, all over 1 minus 1/10. Again, be very careful when you're typing this in. Use the correct parentheses throughout, and we find out that the sum of the first 5 terms in this case is 0.11111. So that concludes finding the geometric sequence and series.